Okay, good morning there, my Delgado students. How you doing?
Good morning. Good.
Good morning, Professor Cruz.
Morning.
All right, good to see y'all. We had a good finish to the week. I know we had a lot of stuff, but it's going to get a little bit meaner because we got by the end of the week we got to cover this chapter 3, which is the logic section, and then we'll have a review and then our test. I got Respondus browser. Hadn't decided about that yet, but you're not going to use Respondus, but I don't know if we're going to use the honor lock or not. What's wrong with this? All right. Well, anyway, in the there's a little assignment in the 020 for you to work on for about 15 or 20 minutes. And then once you finish with that, I'll get to I'll just go over a little bit about the basic things that we'll look at in the next hour because, like I said, yes, we got 2 days to cover it, and so I want to get the basics into this class, and then we'll kind of go a little bit faster. So, all of a sudden, everything's acting weird. Everything was working fine, and now everything is slow as all everything. But in the Alex, there should be in the 020, there should be a little. Okay. And if you got any questions when you're doing it, just ask because I don't mind giving some direction on it. I'm hoping that most of you all have. It's the same kind of stuff, really, as last week when we did this. So.
So evaluation 2, is that what it is?
Yeah, I think it's called evaluation 2. It should be active right now. If there's not, let me know. In the 020. Oh, what's going on with my camera? Well, everything's acting weird today. It was on, and then now it's. going. That's not it. Oh. The first thing we'll look at in our logic chapter is the idea of a simple statement. Now, a simple statement is just a sentence that conveys one idea, and it's got to be well defined, sort of like a set, in that you're going to be able to look at it and know what it's saying to do. It can't be a question, it can't be a command. It's got to be a statement, and that statement has to be something that we can, by looking at it, be able to define what it is. So here's some examples. Mike is a horse. All right. Now, for that to be a true statement, it just means that there's got to be a horse named Mike somewhere. Now, these statements, they don't necessarily have to be true in order to be valid statements. Okay. They just either true or false. They have to have the ability to be true or false. And that's sort of like how it links up with the idea of a well-defined set. Because as long as we can proclaim it to be something either true or false, then it is an actual statement. So fish swim in a stream. That's something that most people could see. Yeah, that would be true. Because somewhere you got fish that are in a stream. New Orleans, the capital of Florida. Now, even though that's a false statement, it still is a statement. because we can assign it a truth value based upon just knowledge. We live here. We know that New Orleans is the capital of the New Orleans is not the capital of Florida. We know that in Louisiana, Baton Rouge is the capital. But that is a statement. Our school mascot is a pig. Well, at Delgado, we got a dolphin for a mascot. But it is possible to have a school with a pig. Arkansas, Razorbacks, probably other places too. So here's things that are not statements. Questions, commands are not statements. So read pages 1 through 4. How much is the doggy in the window? Anything that's a question or a command is not going to be considered a statement. And what we do generally, instead of working with the statement, we assign it letters P, Q, or R. We don't get past 3 statements in here. So P, Q, and R is just like a variable. You define it, the statement, and link it to one of these variables or one of these letters. And then from then on, until you change that definition, whenever you see P, you know what it means. So instead of writing out Mike is a horse umpteen times, we can just use, once we define it as P, then until we define it again, whenever we write out P, we can know that it means Mike is a horse. Same thing with any other one, any other statement. Frogs have fur. Doesn't matter that that's a false statement, but it's been defined as Q and it is a statement. You have these things called connectives. Connectives are ways to put together two or more statements. These are what we call compound statements. We use these connectives. And the connectives that we use are and, or. We've got another one, if, then. It's kind of a 2-part one. We also have another one called if and only if. That one's not used nearly as much, but these are the 3 main ones. And, or, if, then. The conditional statement. Sometimes we'll have statements with quantifiers, like some, all, or no, none, kind of thing. And just realize that those are slightly different, because if you were to say people are crazy without quantifying how many, then it's not going to necessarily be a true statement. And we want to be able to have it to be either true or false. Some people are crazy then has that quantifier, some, to help us identify who, or that not all people are crazy, but there's some subset that is. If we wanted to say everybody, then we do something like we do in that middle one. All students do their homework. Again, we don't know whether it's true or false. Most likely it's not, from my standpoint, because oftentimes students don't do all the homework. Some do. So if we were to attach some to there, we could make it into a true statement. But the thing is, we can use all of these 3, some, all, or none, or no in this case. No fish get eaten. So that's quantifiers. To negate a statement, we can do one or two things. We can do it grammatically. So with Mike is a horse, we can negate. So if P is defined as Mike is a horse, then the negation of Mike is a horse would be Mike is not a horse. And then to negate it symbolically, which is what that P is, then you just put a negation from it in front of it. Because once P is defined, and then you put a negation in front of that letter, then that negates it. That's our way of negating it. So look at Q. As I said, we can do it one or two ways. We can do it grammatically, where the way that most people would normally kind of do it. We do not like ice cream, and then is the negation of Q. We like ice cream. Or you can do it like this. At the front of that statement, we could say it is not the case, or it is false that. So you could also say, so all of those, or both of those methods, essentially, because these two are essentially the same, then we can negate it in either one of those ways. Grammatically, by just throwing in the do not, or negating it at the beginning. And then sometimes you might do this to make it more clear. It is not the case that, in the old Alex, they would do this just to make sure. But if you have something like it's do not case or it is false, it's negating everything that comes. So when we negate, oh, it's down here. Let's hold on a second. So we can also connect them with the or, the and, the if in. So something like this, P, and that's the or symbol. It looks like the union in a way, but it's a V, yeah. But it's really the same thing. It's still going the same way. And that eventually means or. So P or Q, Mike is a horse, or we like ice cream. And then if we want to negate that, then we can do it one of two ways. We can do it with it is not the case, and then Mike is a horse, or we like ice cream. Okay, it's negating the whole thing. We can also do it with De Morgan's law, because this right here is smack dab out of De Morgan's law right there. The negation of that union or then means that we would go to not P and not Q. So Mike is not a horse, and we do not like ice cream. Y'all following along all right? I'm not trying to get too intense here. You know, I said this is just a precursor to what we're going to go over it starting in an hour. So if something is already negated, like if we have a statement, today is not Monday, it's already negated. So if we negate it, you can have it in this kind of awkward way. It is not the case that today is not Monday, which could be easily simplified to just today is Monday. Or you could say today is not Monday. But essentially, the negation is today is Monday. All right. And I'm saying that when I showed you that today is not Monday, it's sort of like this concept in mathematics. If you remember, like if you have x minus a minus 3, because you're adding across, because you're subtracting across the axis from the positive and negative sign, then that's why you end up adding, and that ends up being x plus 3. So today is Monday is the negation of Today is not Monday. And it's obviously easier to understand if you do that. Writing something with two negations in it can be rather stressful to understand. So just remember this little thing right here. This is the summary of it, but I like to look at it like this: to negate the quantifier all. So if you say all people are crazy, then all you have to do to negate it is say some people are not crazy. That's negating the all. If we say some are, then the negation is none are. And so these two negate one another, these two negate one another, going back across that line. So a compound statement is just one that that puts together two simple statements, and we use the connectives and, or, if then, and then if and only if. So the conjunction, it looks like that little thing over the 6. It's the same thing that they use in the calculator, the TI calculator, for exponents. But here it means and. And you'll notice that it looks like an A for and it's the counterpart in the set theory for the intersection, because you're saying it's in this one and that one. You can also say in place of and, but, or nevertheless, but for the most part you'll see and. The or is called what we call the inclusive or. It's one or the other or both, called the disjunction, and it looks like a V, but again, let me show you this. So up here, okay, so over in logic, in logic, we use this one. Over in set theory, it's the upside down U. They're the counterparts of one another. They mean essentially the same thing. And there are some textbooks that use the same ones for both. So V is the to that one. They both mean or. Union is or. Intersection is and. All right, so putting things together. So if we define two statements, and let's say we want to write these symbolically. If we've got a statement, we will go to the store or we will not live, then this is the way that we translate words into symbols. All right, first of all, we're going to assign P, usually the first one we do. We will go to the store. Okay. Now this one's in the negative. So generally what you want to do to make your life a little bit simpler is always define your statements in the positive. So let Q be equal, we will live. Now, if we want to rewrite this with the symbols, then it's going to be P, because it's P just as it stands. We will go to the store. The disjunction right there means or. Now, Q was defined as we will live, but we wanted to have not live. So therefore, we're going to put that negation of Q there. And then that right there, once these have been defined, then here is the way we would write this sentence symbolically. So let's look at another kind of example here. I will eat frozen dinners and I will not live to see another day. So again, we're going to write them in the positive. So P is I will eat frozen dinners. Q is I live to see another day. So now, because we had that negation of this part, so then it's not. Where did it go? So it's P conjunction, not Q. So P is I will eat frozen dinners. Q is I will live to see another day, but we've got the negation there in order to have it be faithful to the original statement. So and or are the two basic ones. The one that kind of a little bit tougher to understand is the conditional. It's symbolized by that little arrow, and the arrow just goes left to right, never right to left. But you just read it as if then. If then. When we have a statement, if, and we can just say something like, if P then Q, then P, the first one, the one that follows the if, is called the antecedent. The one that follows the then is called the consequence. Now, this order is important because basically what we're doing here is we're saying that if that antecedent happens, then it leads to the consequent that we have. So if we want to write this symbolically, if you give me some money, then I will hit the road. This is a promise, okay? That's what we mean by a conditional statement. It's a promise that if this happens, then this happens. So if we define give me some money as P, and I will hit the road as Q, then we can write this symbolically as if P, then Q. So let's look at if we use those same statements and we want to write it, or write this one. If you do not give me money, I will not hit the road. So that one would be not P, not Q. Usually best to keep them small, but like the lowercase, but it doesn't always have to be like that. It's just, that's generally the way you see them. So this one, if I do not hit the road, that one is different. It's twisted around. And as we get further on towards the end, probably tomorrow, We might see a little bit of a day. That one right there is called the contrapositive. And it's essentially equivalent to this one. These two are they're equivalent to one another, even though they're arranged differently. So a little bit later on, like I said, probably tomorrow, when we want to write a statement, an equivalent statement, then we can use the fact that the conditional statement and its contrapositive being equal, we can use that fact to write an equivalent statement. There's other things too. There's De Morgan's laws. Those are going to appear again. All right, so last one we'll do with the conditional. If I do not get a drink, I'm going to cry. So if we've got a statement, a compound statement, and we want to write it symbolically, then we look for all the simple statements. So in this case, P is I get a drink, and Q is I'm going to cry. So then we can rewrite this symbolically as not P, because if I do not pee and do not get a drink, then I'm going to cry. Just plain old Q. So if not P, then Q. And the biconditional can be created using the conditional. But essentially what the biconditional is, it means equivalence. All right. I'm gonna come back to these in the class. I'm just kind of going to go over the highlights of things. So we'll come and look at these in a bit. This is going from words to symbols, so we'll come back and we'll do this. We've already looked at the basics of it. We'll go over this again, and then we'll work some of those out. All right, so that's the basics over there. Writing symbolically from words to symbols, and then symbols to words. But let's talk about these things, truth tables. Now, truth tables are a necessary evil in this chapter. Okay, you're going to have to be able to. It's very much the counterpart of the set operations over there. So, if we want to find out what regions or what values are represented by a set operation, then we essentially are going to work from the inside out, from the most complicated part, until we get the whole statement broken down to represent the final value for that. Well, the same thing is going to happen here with truth tables. But here's the thing is, and an or over there continue now. Okay, they're just going to look slightly different because we got a different symbol, but they're really going to work the same way. But let's look at these basic things. Now, the first thing to look at is the negation. And remember, the negation of something just means the opposite. We looked at the case of today is not Monday, and then we negated the negation, and we got it down to the negation of today is Monday. And if Mike is a horse, the negation is Mike is not a horse. So here there's two cases for the negation. If the statement that we start out with is true, then the negation of it is going to be false. If it starts out false and we negate it, then it's going to be true. So example, today is Tuesday. Well, that's not a good example. Let's change it back to Monday. So if today is a Monday is our statement, then the negation of that would be the opposite. Today is not Monday. So this class meets at 2 p.m. False. No, this class meets at 11 and then 12:30. So that's false. So the negation is this class does not meet at 2 p.m., which is true. True. All right, now that's the only connective that only has two values, or two cases. All right, because whenever you do a negation, you can just do it. You're doing it on one statement. One statement. You can use it on a simple statement. Whereas the and, the or, the if then, the if and only if, they need to be used on two statements. All right, therefore putting together two simple statements. Now, as I had said, the and is the counterpart, or the conjunction is the counterpart to the intersection in chapter 2, the set theory. They both mean and. So this is a little Venn diagram, of course. All right, so let me try to show you using this. Remember, intersection means where do they connect? Where do they overlap? So with a set theory, you can see that blue part would be the intersection. Okay? There's your intersection symbol. And like I said, it's here. We're using it like that, but they're both at least turned in the same direction. All right? So it means it's in both. So let's look up here. So with the and, the first statement is true right in here. Right there. There's case 1. If we're in A and in B, in other words, both of those are true, then the compound statement is true. Another way to look at it is two truths give us a true when they're anded together. Case 2 is P is true, all right, or the first statement is true, so if we're out here, we've only inside of A, we're not inside of B. So that's why this is false. See, a true and a false give us a false, truth table wise. If we're out here on that part, see, we're in B, we're in the second one, that one's true, but we're not in the first one. See, we're not over here because this is the only place where you can be in both. And then if you're in neither one, it's false. And that is simply out here. Okay? So the only time the and is ever true is when both statements are true, when you're in both circles. Now, you'll see a little bit later on that there are truth tables that you can kind of memorize if you like them, and I'll show you that. But I'm not really big keen on memorizing stuff, so this is the way I do it. I just try to remember this statement here that sums everything up. Notice that the conjunction is only true when both P and Q are true. There's only one situation, and that's when you're in both P and Q. In other words, P is true, Q is true, otherwise it's false. See that? There's 3 falses. Only one or the and is true. And that's essentially just like the concept of the intersection. All right. All right. Look at or. This is like the union. Notice that in a way, it's kind of like the opposite. This time you've got 3 truths and 1 false. Well, that 1 false is when you're out here. Because you remember that outside of the union, outside of the 2 circles, that was the not. That's the neither A nor B. Well, that's this one here. That's that one there. But to be in the union, if you're in here, here, or in there, it's true. So it relates back to the concept of the union. I'm not going to create any truth tables here. We'll do it in the second class, just because it's kind of a tedious thing to do. So I'm just going to try to hit the concepts. But basically, what it is, it's just like doing set operations. You first of all, you start in the innermost place, the most complicated place, and work your way out until you're done. And just like with the set operations, you're going to have one set of values that represent that set operation. Same thing is going to happen here when we create a truth table. You're going to have one column of T's and F's that represent a given statement. There's the basic ones, the and, the or, the if then, and the if the if. But if you're creating one, you use these 4 plus the negation to build it. And then lastly, the one is the, hold on a second. This right here goes up, wait a second. Oh, this is it. I'm sorry. Yeah, that was the or. So here's the if then. And again, I'm trying to break it down into ways that it mirrors what we're going over in the first chapter. All right, with Venn diagrams. So there's only one case when this is false. All right. And I can't emphasize enough that order is important. The one time that it's only false is when the antecedent is true and the consequent is false. And the reason why that's false is because the conditional statement is a promise. So if I promise to do something and then somebody does it and then don't get what was promised, then that's a false statement. So let's see if I can kind of show you a little bit with this thing how this works. So if the antecedent is true and the consequent is true, then we got a true statement. I'm going to skip this one for a second because I'm going to come back. That's when I was just talking about the promise. If the antecedent is false and the consequent is true, all the better. It's still a true statement. If the antecedent is true and the consequent is false, then still a true statement. So there's only one scenario where the conditional statement is false. And that's when the antecedent, the first operator, is true, and then the second one, the consequent, is false. So it's the same kind of thing. See, if we're in A, we're also in B. So this gives us an example of how the conditional statement works visually. But if we're out here, we're not in here. So that's why this is the one that's false. Okay, because that means we're out here and we're not fulfilling it. All right, let's see if I can hit a couple of little things. Oh, and then this thing called, and there's different ways to do it. I don't think this Newton used anything other than if then. I went through them early in the morning and I didn't see any that did that. But the last operator is the biconditional, and that is really the same thing as just equivalence if they're the same. So look at this. So the biconditional is called if and only if. So if both are the same, antecedent and consequent are the same, then that's true. So it doesn't matter whether they're both truths or both falses. They're still going to be true because they're the same. Like I said, if and only if. If they're mixed in any way, in other words, antecedent true, consequent false, or antecedent false, consequent true, then we got a false statement because they're not equivalent. As a matter of fact, my son took a logic course like in high school several years ago, and I was helping him with it. And they just they call it equivalent. So, I mean, it's the same thing. You know, that may help me a little bit understand it a little bit better too. Because as long as they match, it's true. If they don't match, it's false. And then, of course, that's the Venn diagram that they're both the same thing. They're both the same set. Let's see. I think this might be the last thing that I want to show you. These last few little things for today. Self-contradiction is just a compound statement that's always true. When you do a truth table, you can tell because all F's on a truth table. We haven't done a truth table yet, but let's see how to do it. And the tautology is all T's. Okay, all T's. And then a tautology is we get, tomorrow we'll see when we talk about the arguments, that a valid argument is going to always be a tautology. You got to have all T's to have a. We don't need to worry about this implication. I didn't see that in there. That's just another way of saying a conditional statement is a tautology that I just mentioned. So here's the summary of these things. This is the way I like to think about them down here. And then here we got the and, TFFF, or is TTTF. The if then is TFTT. And again, order is important. Order is important for that one. Notice that for this one, true, false, that's the false one. But we can turn them around, false, true, and it's true. And then the biconditional is just if they're the same. Two truths is true. Two falses is false. So one thing that I would suggest, because like I said, this is all going to come quick, because in the second hour I'm going to go through half of this and show us how to do truth tables. These are the ones you just got to know them. So I would recommend like either printing that out or putting it on phone while you're doing your homework to get used to that, because you got to know these 5. They're all different. See that? There's the negation. So if something's true, the negation is false. If something's false, the negation is true. The or, the and, the or, the if then, and if the only if. So when I'm filling out a truth table, which is what I'm going to do in the second hour, about halfway, this is where they're coming from. Okay, that's where they're coming from. So I'm going to take a little picture of that, and then I'll be able to bring it up while we're working. So that's enough for today in the morning. So at 11, at 12:30, we'll go through this again and do, more exercises. So if you got any questions, stick around. We got a few minutes here. I'll be happy to help you if you got any questions. So otherwise, I'll see you at 12:30.